I think if you want to grab a chair, we'll get started. Welcome to Bug Fest. And if you see anybody, stomping their feet, that's probably, a control mechanism, right? So we'll just kind of see how that all goes. But welcome. It's jointly sponsored by the Burleigh County Soil Conservation District and by the NRCS, which is the Natural Resources Conservation Service, and the Morton County Soil Conservation District, and Dakota Prairie's RC&D. So those are the sponsors. My name is Jay Fear. I'm just going to open it up today and turn it over to Jonathan Lundgren in just a moment. But I got thinking about diversity a little bit in my opening. And so there's a really great book for all North Dakotans. It's, if you live in North Dakota, Early History of North Dakota. So if you haven't read it, I would encourage you to do so. It's Clement Lounsbury. He was the first editor of a newspaper in North Dakota, which was the Bismarck Tribune. And so if you haven't had a chance to read this book, you may want to. It's got some interesting things in it. So when you're thinking in terms of diversity, when did we start to switch from prairie to cropland in North Dakota? Who was the first farmer? Do you know the first farmer's name? Do you know what year he started? And you'll find some information in the book like that. The individual's name was John Tanner, and it was in the northeast corner of North Dakota. And the year was 1801. And he was there because of the fur trade, as many other people were in the northeast corner. And anyone want to guess what the first crop was? What was it? Any? Potatoes. Yes, potatoes, exactly. He also grew some what he called garden seeds. And he harvested a bushel and a half of potatoes, and the horses ate the vegetables. So I think it was a win-win. So that was 1801. Then he recorded his take in 1804. And it was kind of interesting. October 22nd, the crop gathered was 1,000 bushels of potatoes. And it was the product of 21 bushels. I think that was probably a pretty good harvest. So that was in 1804. He also harvested 40 bushels of turnips, 25 bushels of carrots, 20 bushels of beets, 20 bushels of parsnips, 10 bushels of cucumbers, 2 bushels of melons, 5 bushels of squash, 10 bushels of Indian corn, 200 large heads of cabbage, and 300 small heads of cabbage. And this was exclusive of what had been eaten and destroyed previously. And so that was a pretty good harvest. And so that was kind of the start. But when you're talking diversity, obviously the start meant the end for something else. And so that was when our prairies started to go out, and we went from high diversity grasslands to more of a monoculture type cropping. My wife and I did a couple workshops, soil health workshops in Wisconsin a few weeks ago, and I was visiting with the locals about crop rotations because I'm an eternal optimist. And so I asked them, I said, what are your crop rotations? Well, they said, we got 3. I said, that's more than most. Yeah, they said, we got corn, we have bean, and we have corn bean. And I said, okay, I get it now. And so it kind of helps you understand how we have gone from this high diversity grasslands to something much more of a monoculture. And then we start to take a look and ask ourselves the questions about, well, what impact did that have? What impact did that have in our pollinator world, our insect world? What are those impacts? And so tonight, we've asked Dr. Jonathan Lundgren to be here. And he is an agroecologist and CEO for Blue Dasher Farms in South Dakota. And his research and education programs focus on assessing the ecological risk of pest management strategies and developing long-term solutions for regenerative food systems. And so with that, we're going to ask him to come forward and share with us this evening diversity in pest management. And I think, is it safe to say that you would entertain questions as you go, or would you
Sure,
prefer?
yeah, if people want to fire them away, and if not, I'll
Okay.
just kind of steamroll over it, and we'll go from there. So,
Love it.
one way or another.
So it's going to work out
We'll
either way.
save time at the end, too. It's always nice to have dialogue afterwards. And
Now, keep in mind, and instead of, I want you to do something this evening. Instead of clapping, I want you to assume that you have antenna on your head, and I want you to send him a signal,
yeah.
a welcome signal through your antenna to his antenna on top of his head. So don't clap. Okay, come on. So send him. Don't clap. Don't clap. Send him the signal. Send him the signal. Come on.
All right, I feel better
Thank you very
already.
much,
I feel at home.
Dr. Jonathan Lundgren.
All right. Thank you, everybody. It's good to be back in Bismarck. I'm trying to think when I was here last. Not too long. Actually, I spoke to the Wildlife Society here back in, when was that? Maybe February? Yeah, that was a good group. They got all riled up. It was wonderful. I worked for USDA for around 11 years. Last year, at the beginning of 2016, I quit because I believe that the future of food production is going on right now and that it is being led by the farmers themselves. And so we wanted to get out of the current infrastructure and do something a little bit different. So we have a research and science company called Agdisis Foundation and Blue Dasher Farm. We're tying all of these principles that you hear about at Minokan and things like that, we're tying our own success as a business to us putting those practices into play on our own farm. I'm not just talking about it, we're actually doing something with it, right? I'm an entomologist by training, okay? But as I studied insects over the years, and yes, they are the best, and so it's important to realize that, but we also, what I came to realize also is that insects are just one part of a much bigger system. And that oftentimes as scientists, we love to focus on our little component, our little fragment of this larger world, without considering where that fits. And what really started to, when I started to meet guys like Jay here and farmers that are putting these things into practice, many of which live, like at Kenny's place and Gabe Brown's place and Jim Doan's place. These guys understand where all of these different pieces of the puzzle fit together into a very functional system, okay? So, I'm going to talk a lot about bugs over the next couple of days, but always bugs in context, right? We're using insects to illustrate how biodiversity works, okay? If you guys have seen me speak before, you've seen this slide, right? This, when I tell farmers that I'm an entomologist, this often is what I'm told, right? Oh, the only good bug is a dead bug, right? That is not what I believe. That is not the truth, right? Because insects are the most diverse group of animals on the planet. And we love, as land managers, we love to focus on the problems, don't we? We love to focus like this thing that I just broke of Jay's. That's a horrible thing. We love to focus on the problems, right? There's a pest. There's a pest that's eating my crops, right? And I got to kill it. We got to kill it. That's entomology, right? That's insects. We've got to kill this thing. I don't know if this has any hope. We'll talk later. We've got to kill these things, right? There's a pest out there. Insects cause a lot of problems to crops. They cause problems to livestock. They've killed more soldiers than bullets or bombs have through disease transmission, right? But when we just focus on the problems and ignore the rest of the system that produced that problem, it is to our detriment. Insects are the most diverse group of animals on planet Earth. For every one pest species that's out there, there's actually around 1,700 species of insects that are helping us. So when all we do is knee-jerk and kill the pest without figuring out what's going on with all those other beneficial species that are out there or neutral species that are out there, then that is when the system breaks, okay? That is when the system breaks. What are the benefits of bugs? They are the basis of complex food webs. In a nutshell, biodiversity feeds off of itself, right? You can't have one without the other. And insects are a critical piece to a healthy biological system. Anybody like to go fishing? Anybody like bird watching? Things like this? Hunting? Any hunters? Nobody? Well, all right, there's some hands. Okay, that's good. If you do, thank a bug, because insects are the food that supports many of the species of wildlife that we rely on. All right? Pollination. Pollination services. Anybody like fruits and vegetables? Any fruits and veggie eaters? Yes, there's hands. All right, we're good. If you do, thank an insect, because insects are pollinating many of the crops that we currently rely on. There's great pictures on the web of like the produce aisle with and without pollinators. And it's pretty stark. It's pretty bleak when you don't have pollinators in the system. It gets to be real simple. No bees, no plants, no people. All right? And there's at least one beekeeper in the audience. We're losing currently in the United States around 30 to 50% of our hives every year. 30 to 50. Imagine losing 30 to 50% of your crops, or 30 to 50% of your herd if you're a cattle rancher. Is that acceptable? When asked, some of the regulators shrug their shoulders and say, well, they can make more. I mean, they just make splits off of the current hives. It's like, oh, well, those cows should just reproduce. You know, that's what they should do. That'll take care of the problem. No more problem, right? We'll talk more about that. Tomorrow night, we're serving up crickets. Come on out to the Minokan farm if you would like to try it. It'll be a delight. Insect, if you like things like lobster, crab legs, sorry folks, it's a big bug, okay? And European cultures, namely North America and Europe, are two of the only cultures on earth that do not rely on insects as a major source of protein in their diet. So we're about to change all of that, right? Tomorrow night. We think of diversity in the soil, and we think of biology in the soil, and instantly we think, okay, microbes, right? Microbes. Microbes are important, but microbes do not exist or function well without bugs. Insects like dung beetles, decomposers, these things are how they make the nutrients available to the microbes to feed the next generation of plants. That's how these cycles work. So we need them. Insects are nature's herbicides, they're nature's insecticides. We can use these beneficial species to control our pests. All told, entomologists estimate that insects provide about $63 billion every year in services to society in the United States. $63 billion. That's by far an underestimate, okay? By far. We think of our agro ecosystems, a lot of times we think, well, it's meant for growing food, right? We're supposed to be growing, you know, maybe it's corn, maybe it's soybeans, like the 2 rotations that we've got in North Dakota. Maybe it's something else. It's not supposed to be growing. I mean, biodiversity occurs elsewhere, right? It's supposed to be happening in the rainforest down in South America or Madagascar, right? Biodiversity doesn't happen in North and South Dakota, right? We give a lot of recommendations. If you've got this pest, buy this jug and squirt it out there, and you don't have to think about your pest anymore. It's an insurance policy, right? You buy a jug. We were giving in South Dakota a lot of advice on what jug to buy and what type of seed with every package that you can imagine on it, that corn farmers had better plant or they're going to lose their crop this year. When I looked in the scientific literature, I found that there had never been any sampling done as far as where and when pests and other insects were occurring in cornfields in South Dakota. We were giving advice to farmers without any data, you know? This is a problem. So we set about trying to stop that. We went out to 53 different farms in eastern South Dakota, and we looked. They had to be 10 acres in size. They spanned a range of different conditions, production conditions. They were all supposed to be non-BT corn, which they were, because we wanted to study all of the insects, including the pests that were out there. And then we also wanted no insecticides on them, but we quickly realized that that was not possible. That many of the farmers were applying neonicotinoid seed treatments to their cornfields and they didn't even know it. So they were paying for insecticides that they were putting out there to control unknown pests, but it was costing them money, right? So we had to go with minimal insecticides, the low rate of those, and if they used the low rate of seed treatments on their cornfields, then we allowed the study in. What did we find? We looked at a lot, we spent a lot of time on this study. And in just the corn canopy, we found 107 different insect species. This was anything with more than 4 legs and anything with less than 2 legs. Okay, that's what's classified as an insect for this. Of these, only 7% were primary pests. Okay, 7% of those species, but none of them, in spite of these not being used, or not using BT, and for the most part no insecticides, none of the pests were at economically threatening levels. Okay? If you are if you're paying $200 a bag for corn seed to kill pests that aren't even there, I'm sorry, that's dumb, right? That is a bad business decision. That doesn't mean, oh, Lundgren hates neonics. Lundgren must be anti-GMO. We don't have to listen to this. No, the data is very clear. That is dumb from a business perspective, okay? If you want to lose money quick, then that's a great way, all right? 13% are neutrals. They do not seem to have much of an impact. Most of them are actually predators. Most of the insects that we found in cornfields were predators. These are things like lady beetles, lacewings, insidious flower bugs. There are things like ants, spiders living on the plants, eating your pests if we'd get the heck out of the way and let them do it. Let's see. Okay, good. So, if we have all of these predators, why do we still have pests out there? This is the central question that challenges me because a lot of entomologists are very pest-centric as well. They see a pest and, okay, let's figure out the threshold. How many pests before we spray? How much do we spray? When do we spray? How do we spray it, right? And I come from the perspective, what's causing those pests, right? How can we change the system so that we don't have pests to begin with? So this is the question that goes through my mind all the time. If we've got all these great things, then why do we still have pests if we have all these predators out there? And the answer is right there. What kind of diversity did we replace? You know, if we've got 107 species in our cornfields, just the canopy, that seems like a lot, but what used to be there? I had a graduate student, he finished up his master's, he's now getting his PhD, almost done. I'm trying to hook him back into coming up to Blue Dasher again to do a postdoc with me. He looked at prairies in Brookings County, South Dakota, pastures, those are 2 perennial habitats, and then cornfields. And we did bioinventories. We looked at everything, right? We did plants, transects, and quadrats out there to look at the entire plant diversity in these different systems. We looked at the bugs. We crawled around on our hands, and we used a vacuum cleaner to suck all the insects off of the foliage. And then we got on our hands and knees like these guys are doing, and we had a little straw that we sucked up any bugs that were on the soil surface. And then we took a core, a golf cup cutter, and we drilled down into the soil, and we chased all of the bugs out of the core, and we found out how many bugs were in the soil column. It's a hell of a lot of work. We found 350 arthropod species. That's insects, more or less. Thousands, almost 3,000 specimens, 75 plant species. We did find one pair of identical twins out there. I don't know what they were doing. Most of the diversity of that community is these little guys. These little guys. These are wasps, but they don't sting people, they sting other insects. And they lay an egg inside of other insects. For every insect species, we entomologists estimate that there's at least one species of wasp that stings only it. It is the most diverse group of animals on the planet, are small parasitoid wasps that most of us just dismiss as gnats, right? Because they look a lot like gnats, which was the other group of very difficult to identify insects out there, which was these little minute flies that are a royal pain in the neck. This is what we found. Species richness in the prairie, in the pasture, and in cornfields. Cornfields have about a quarter of the diversity that used to be there. Okay? That's important. That's important. Why is that important? With that kind of diversity, it's really difficult to understand all of the potential interactions among species that would drive when and where a pest is becoming problematic. All right? Because it becomes a web. It becomes a web. It becomes a network, a biological network. So we turned to the sociological sciences to try to understand these complex communities that are in cornfields right now. All right? 7 Degrees of Separation from Kevin Bacon. Have you ever heard of this before? Everybody in this room knows the actor Kevin Bacon through 7 acquaintances of acquaintances. It's all done with fancy-dancy statistics in order to understand how information travels through the World Wide Web, how social networks work, within communities, things like this. Well, we adopted that technology and put it towards biology. Much of what we understand about networks of species comes from simplified systems. We take a pot, a black plastic pot, and we put a corn seed in there. And then we put a pest of that corn in there, and then we put a cage around it, and then we put a predator in there, maybe another predator in there, and what happens, right? It helps us to understand because we simplified the system, right? We simplified it so we can understand it. But it ignores a lot of the complexity of the natural world. Here's a great example of this. This is a network, right? This is a community in corn. There's the corn plant. That is the base of the food chain. Here you've got your European corn borers. Aren't they cute? Those little caterpillars, they're just snuggly bugglies, right? They're walking around. But as soon as they kind of drill into the corn stalk, you never see them again. And so they're very difficult to treat. That's why Bt corn was created, right? To control this pest. A scourge. It is a scourge. We like to kill those. And then over here you have that little alligator dude. That is one of our lady beetle larvae, and they love to eat the European corn borer's eggs. And up there we see Macrocentris grandii, or Gifwensis, depending on which systematist you talk to. That is a parasitoid wasp, and it only stings European corn borers, up to 30% of the larvae, actually, of the caterpillars. And so this wasp, just like you guys greeted me with, it's got its little antennae out there, right? And she smells with those. That's how she's smelling. They're almost all females. Few males, mostly females. And then she finds the corn stalk that's got your particular pest on it, and then she walks up and down, and she knows, without any external signs, where in that stalk the corn borer is living. And she uses her stinger not to sting us, but to lay an egg. And she drills through the corn stalk and into the caterpillar and lays an egg right inside. And then the wasp larva eats the caterpillar from the inside out. Reproduces. From one egg, she produces dozens of offspring. And so that caterpillar essentially becomes a little sack of baby wasps. Very cool, huh? Is that cool or what? See, I told you entomology was great, right? So what happens when you pluck something out, right? Everything must, what happens to the reliance on the corn borer of the wasp when the lady beetle's not there? Very simple. It's all easy to understand. Remember those 53 corn farms? We generated biological networks based on those. Each of those dots in this big old hairball is a species. Okay? And if it's statistically correlated, its abundance is statistically correlated with another species in that web, we drew a line. What happens, so if this is a pest, what happens when you pluck that out? We hate pests, right? So you pluck it out. And you find that it's connected to species that are connected to species that are connected to species. That's important. What's going on over here is what determines whether you've got an abundant pest. So why are we focusing our management on reacting to this son of a gun when this is the problem all along? Each dot is a cornfield. Down here we see pests density. Up here we see species diversity within that cornfield. Cornfields that have a lot of bug species do not have pests. When you've got community evenness, a balance of species within your corn community of insects, everybody is always at the same level, not like one that becomes really abundant on you. What happens? As that community becomes even in a cornfield, you do not have pests. This is that hairball I showed you before, except I pulled out the major components. This is a cornfield that has low pest abundance. Look at the connections going on among all the species here. This is a cornfield with high pest abundance. It's broken. It's broken. Where's the connections, right? Those species aren't either not there or they're not interacting with each other anymore. What decisions increase diversity in a cornfield? How do you increase diversity? What practices can you use? Anybody know?
Along the margins, you can plant all sorts of different plants that provide habitat for multiple critters.
That's right. Conservation strips along field margins. Cover crops make a lot of ecological sense. Interseeding in your corn rows. You've got 30 inches of bare soil in between those corn rows. Fill it up. How do you reduce diversity in your cornfields? By their very definition, agrochemicals are an addiction. The more you use, the more you need. Okay? Who wins in an addiction scenario? Is it the addict? It's the guy who's pushing the drug. Are the farmers winning right now? Nope. Wise up. All right, we're going to miss this part because I want to talk more. I know you guys have all been waiting. When is Lundgren going to show us a big pile of cow crap? Wait no more. It's here. It's here. Look at that steamer. Huh? We're moving into rangeland systems now because we've been working more in rangeland systems, and it's really, really cool. It's illustrating some of the same ideas that we're finding in cropland in a totally different system. Why is dung removal important? Ask an Australian. When they introduced cattle over into Australia, they didn't have dung beetles. They ended up having so much pasture fouling, they literally rendered their pastures unusable because of all the cow crap that accumulated. Until they came back to North America and Asia and did a classical biocontrol introduction of dung beetles into Australia to try to combat that. They also are still suffering from the fly load that ended up accumulating in their dung pats. So, can we remove pats in order to feed the soil and the next generation of plants, as well as eliminate many of our pest species that all have a dung-dependent life stage? Things like pest flies and worms, okay? Entomologists estimate, and this is all based on numbers from the 1980s. We're hoping to update these numbers now that we've got some really good data out of South Dakota. $380 million just from dung beetles that it saves ranchers every year. Okay, that's in the U.S. I did not shoot this pat with a shotgun. Those holes you see that is from insects, right? That is from insects that have opened up that pat and allowed a whole biological community to infiltrate. The services of dung beetles and other insects, they include nutrient cycling, they increase the pasture quality. Where's the healthiest places in that pasture? Where is the grass the greenest? It's where those pats have been incorporated in. Okay? And pest suppression. These numbers are 40 years old. We are now changing that. We wanted to study the contributions of bugs to poop degradation, okay, in pastures. The pats were either caged or uncaged. We built these little great cages around them to try to keep all of the insects out of those pats. And then we looked at how the pats degraded over 42 days. This was all done by one of my graduate students, Jacob Pachenka. So what we did is he collected these, he took a core, and then we brought it into the lab and we put it into the cylinder with a light bulb on top, and then we warmed that cow turd up, and as it warms up, all of the insects try to escape and they get caught down. And this was probably the most disgusting project that we've ever run in my lab. We wanted to get some t-shirts that they said, "Oops, I got poop on the blank." And if you filled in the blank with any particular word, chances are pretty good you were right at some point or another during this project. There was turds. My wife is not happy about this. To this day, she still blames us for that. But this allowed us, really for the first time, to have a comprehensive bioinventory of insects that are living in turds in North America. Believe it or not, there has not been one done like ever. Certain groups they've focused on, beetles, we've got some information on, but the entire community, no. We actually collected these numbers were put up there during the process. We identified 2 species, 200,000 insects as part of this study. Okay? We actually got 175 species of insects living in cow turds. 175 species, of which 20 were dung beetles. Dung beetles represented only 3% of that community, but they get all the press. We'll talk more about that in a minute. Oh, great, another bar graph. Just what we wanted, right? Okay, I'll talk you through this. Arthropod abundance. This is how many bugs we're finding per meter squared of poop. And this is the age of the pat. This first one was collected early in the season, right in the spring. And this one was collected in the middle of the summer, in the heat of the summer. What did we find? Number one, 517 insects per pat. 500 bugs, right? That's a ton of insects, almost literally. Communities totally changed as that pat aged. The reason we're able to maintain so much diversity is because the first bugs ate something totally different than the next insects that moved in, and then there were specialists on the old crappy, well, that's a poor choice of words, the more degraded pat. They moved in at the end, and so you get this incredibly diverse community. But if you don't get, most of those insects all get in there in the first 7 days of the pat. First 7 days of the pat. This is the organic matter, the weight of the organic matter in the cow turds over time as those pats aged in the early season and in the late season. What we see is the slope of those lines are very similar. What's different is that when we include the insects, in the first 2 days, the weight of the pat drops. Boom. Those insects, if you do not capture those bugs in your cow turds in the first day or two, you lose out on most of the services that those insects can provide you. Okay? That is the take-home message. The biggest contribution of bugs comes in those first days. How do you get so many bugs into your system? So I said that dung beetles represented 3%, and they get all the press, right? We've got economic values that have been stamped onto dung beetles and all their contributions. Why is that? They were 1.5 to 3% of the community. But take a look at this. Dung beetle diversity is down at the bottom, and this is arthropod abundance. This is how many bugs were found in each pat. What we find is that the dung beetles, as they became a more diverse community, drove the abundance of all the insects in that system. What's going on there? Dung beetles are some of the largest insects that you find in these dung pats. What happens is that almost instantly that pat gets a skin over it. The dung beetles punch through, and they establish a highway system that the rest of the insects use to degrade that pat. No dung beetles, nothing else comes in. They're, by their definition, therefore, a keystone species in an ecological sense. I don't think we've... There may have been one study in the 80s that showed this going on as well, but I don't know that we've got... This may be the only study that's really put hard numbers on that. Really cool to understand, really for the first time, what's going on in those dung pats. I didn't show it. I should have. Oh, shoot. I'll show it tomorrow. That'll be a hook, right? What happens when you use Ivermectin in your cows, right? What happens to these relationships? We'll talk more about that tomorrow. I'll use some of my time for that tomorrow. Dung insects drive the degradation of cow pats, okay? This colonization has to occur right away. You've got to have a healthy system where they can react and cause and open those pats up to degradation. And dung beetles are really important. Even though they're a minority within that community, they are driving so many things in that system.
Can I ask a question now about the IGR?
Yes.
Clearly the degradation of the cow pies is important for recycling the carbon and the minerals and everything else in the ecosystem. The IGR, as I understand it, prevent the flies from...
What are you talking about when you say IGR?
Insect growth regulator. It's a type of pesticide.
We use that in lick tubs, and what is sold to us when we buy our lick tubs and that is that the IGR will prevent the flies from changing from a maggot into a flying insect, and will not affect the number of dung beetles and the recycling of the minerals from the cow pies. In other words, when I go up and buy my lick tubs, take them down to my cows, I'm controlling supposedly flies and not bothering dung beetles with this.
So, bottom line, and you're going to hear this over and over again if you're, you can believe it or not. The answer to pest problems is not in a jug, okay? It's not in a jug. No matter what the marketing on the jug says, no matter what the label says, the answer is not in a jug. Ivermectins end up, which are the most commonly used of the pesticides that you put into your animals, exacerbate maggot problems more than reducing them. We've got the data. That's what I'll show tomorrow. We find that if you manage your herd in such a way with a high-intensity grazing system that's been adapted for your plant community, frequent rotation, that those people who have abandoned pesticides in their animals have fewer maggots than the ones that are using the ivermectins. Okay? Number two, ivermectins are a hormone surrogate, right? They are replacing a hormone, juvenile hormone within insects. And each insect has a unique juvenile hormone molecule that it relies on to molt. Ivermectins can be more specific for a particular group, but they are not completely specific, okay, for flies. We are only beginning to understand the complexities of and the diversity of the structure of the juvenile hormone molecule in each and every one of these different species of insects. So, insecticides kill insects. That is their job. It says it right on the bottle, okay? I think that we need to think outside of the box a little bit deeper, okay? A little bit deeper. I think we need to solve the underlying problems that are producing the pest rather than looking for a quick silver bullet that's going to do just what we want and never hurt anything else in the environment. And so that's kind of where I come in on the IGRs.
Can I ask another question?
Yeah, please do.
Diversity.
Uh-huh.
I think it's relatively clear that a monoculture is less diverse than a native prairie.
Right.
But a native prairie, while it has a large number of things, does not necessarily, a pasture does not have to be a monoculture, in my mind.
Yeah, I hope it's not.
And so you can create diversity and still have grazing.
Yeah.
And I think that probably you will have greater diversity in your insects too.
Yeah, oh, I'd love to study that in our dung, looking at cow diets and how that affects like a diversity of plant foods that the cow is eating and how does that affect the dung arthropod community. Oh man, I'm jotting things down as far as this system and what I'd love to tap into, and that's, I think, going to be a good one.
But you realize we have to manage that right now anyhow.
That's right, for many other reasons. I mean, yes. And that's where, I mean, we often think, oh, okay, yeah, well, all he's talking about is bugs here. Bugs are just one part of the system. I mean, they're just one part, right? But we need to value the entire system. We shouldn't be just valuing one component of it, right? And that's hopefully going to be a take-home message as we wrap up.
Can I just make a quick observation?
Yes.
One of the things, and not to pick on the NRCS necessarily, but frequently kids are coming out of college educated in ecology, and it's ecology as it existed 300 years ago without people. And on a farm, basically, it is a different ecology with different components to it, and trying to get back to something that was 300 years ago is never going to happen. Can't, because the components are no longer there. If you compare everything to that as opposed to what is a diverse agricultural system of what we have available now, would appear to be more productive.
Right. Nope, absolutely. So there are many ways, and that is one of the major principles that I feel are driving regenerative systems right now. So I've met a lot of farmers from around the world that are starting to go down a regenerative model for production. What are we talking about there? Regenerative focuses on soil health and soil conservation, as well as biodiversity promotion to grow healthy food profitably. Okay, those are sort of the four elements. In many ways, in some ways, these are different from organic, in that I think they're using pesticides occasionally and agrochemicals in order to maintain that system or transition their system. But I think that what they do is capture the spirit of organic that has been lost with a label. Right now, I've been to some great organic farms. I've been to some really crappy organic farms that get the label, right? That aren't farming in the spirit of organic. And regenerative models, I think, really captures the focus of what organic evolved or began as. So in every case, farmers were using different practices, right? But there were principles that united these farms, that were universal and that always seemed to work. Okay? Number one is that they eliminate tillage or reduce it in tillage intensive. Recognizing that tillage is extremely damaging to the soil biological community, as well as many other aspects that Jay could probably go on on about. We would love it if you would, perhaps tomorrow. But when you've got to till for like a root crop or something like that, you take steps to try to restore and recognize the sensitivity of that biological community, okay? Number two thing that these guys are almost universally doing is that they always have a living root in the soil. The idea that fallow is a good farming practice is a myth, okay? It's an unfortunate myth because it's really set us back in a lot of ways. You have to have a living root in the soil to support the biological communities that drive your system. When you eliminate that, you have to replace it with something that's in a jug, right? Some plant diversity is better than no plant diversity, and more plant diversity is better than less, right? Some is better than none, more is better than less. And there are agronomically approved practices or substantiated practices that allow us to diversify our cropping systems in ways that promote crop production. These are things like diversity in your cover mixes. Yes, I'll take a rye cover crop. I'd much rather have a 12-way mix or something diverse out there, okay? Yes, ma'am.
Dr. Lundgren, we also have some small and large gardeners in our audience.
Right.
Do these...
These are perfectly applicable to, to those systems as well. I just planted our no-till garden this last a couple of weeks ago, and you should see our tomatoes. There's photos posted on our Facebook account. Cedric helped. Cedric knows all about our no-till garden. More plant diversity is better than less. Interseeding. We've got to be filling in these interrows, folks. And I know that there are going to be some antagonistic interactions among plant. We need to figure out which ones are synergistic and start testing for those. That would actually be a great thing for Minokan Farm to help out with if there's a possibility for that. Last but not least is these guys are integrating livestock and cropping systems. Livestock does not just mean cows. Chickens, bees, cows, sheep. We just got hair sheep on our own farm. Those are sort of 4 central principles that seem to always be present on these successful farms. We could talk more about that if you'd like. Bottom line is I think that we need a much humbler approach to pest management. We need to be thinking about where pest management fits within a grander scheme, okay? Within a grander system. I think fundamentally, it was funny because, so Josh Dukart, you guys know Josh Dukart? He's from around this area. He's a brilliant guy. If you ever have a chance to listen to him, please do so. Odette Menard, have you ever seen her? She's an earthworm lady. We were all speaking down in Australia last summer, and every one of us independently had a separate slide that said why. That was the only question on the slide. That was the only word, a big question of why. Okay? And I think that question becomes the most important thing in driving so many different aspects of our lives. We often focus on the metrics that we're presented with, okay? So I'm a gardener and I got, how many different bushels of tomatoes this year, or how many, or maybe at my job, I got that promotion that I've been wanting, and I got I did this project and I got patted on the back, and that's why I'm here, right? That's the reason. Those tomatoes, that's why I'm here. I'm a rancher, pounds of beef per acre, right? That is why I'm here. I'm a rancher, I raise cows. I'm a cropper. I'm after 300 bushel corn every year. That's why I'm here, right? Is it? What drives your decisions? These are questions that we really have to challenge ourselves with on a regular basis. It's one that I challenge myself with, I know. Why did I start 2 new companies? Because this world is currently facing some major challenges, right? We're facing climate change. We're facing pollution at an alarming rate. We're facing all of these different aspects. And just talking about it is not going to help. We need to take action. We need bold action, don't we, in order to solve these issues. So last year we reached out to the farmers and the ranchers and the beekeepers and supporters from around the planet, and we asked them, if you believe that regenerative agriculture is a potential future and you think that this is important, then consider supporting it. And we crowdfunded a research facility and a demonstration farm. That's never happened before, through small donations from all over the world. It really validates that there's something going on right now, okay? And Minokan Farm and what's going on in Burleigh County are an incredible part of that. So I would not be here without an amazing group of supporters. We have an amazing team of young scientists that have allowed us to explore all of these different areas and make coming into work every day a hell of a lot of fun. If you guys would like to know more about who it is and what we are doing, those are our websites. You can follow Blue Dasher Farm on Facebook and Twitter. We are on there, or search my name. We also have a sign-up sheet out at the registration desk. If you guys would like to get on our email list, please put your names down, because we try to get newsletters out to people and stuff like that. And we are also doing a fundraiser. If you would like a Blue Dasher t-shirt, like we are all wearing right there, you're more than welcome to talk to me afterwards. And with that, we can talk more. How about? We can open it up for a little bit of questions, or are we getting late?
We can open it up with some questions.
Okay.
Just had 2 housekeeping things before we do that.
All right, let's do that.
Okay. And then we'll open it up for questions. I just wanted to let the group know that the centerpieces this evening, if you've got a dot under your chair, you're welcome to take home the centerpiece.
Ooh.
So you can check that when you feel like it, but there's dots under some chairs and not under others. And if you have a dot, please take home the centerpiece. The other item I was going to mention to you is tomorrow at 1 o'clock there will be a crop and pasture walk at the Minokan Farm, where we can take a look at pests and predators. And so that'll be at 1 o'clock. The Minokan Farm directions are on one of the brochures that are on the table. I think that would be the simplest way. It's the first exit east of Bismarck, exit 170. So exit 170 east of Bismarck, 1 mile south, 1 mile east, half south. So it's pretty simple to find. Or if you know where the St. Hildegard's Catholic Church is, half a mile south. So if you end up in the church instead of the farm, you still did pretty good. Okay? So I just wanted to go through those 2 items, the door prizes, dots under the chair, and then the walking tour. Also at 6 o'clock tomorrow evening is the garden tour. And Dr. Lundgren will participate with others, and we'll be doing the garden tour. So you're welcome to that as well. So with that, I'm hoping we can open it up to some diverse questions and see where it goes from there. So I'm going to turn it back over to Dr. Lundgren.
All right.
I have a question for you, on your
Yes.
basically recently there's been a lot of endangered species being listed and such. And with the change in our diversity across from what was brought in about, or Jay brought into about first farms, away from native and back into what we have a monoculture cropping, what has made the selections that they have, like say rusty patch bumblebee, yellow banded bumblebee, Dakota skipper, such an incredibly focus versus all the other insects. Probably not there.
Would you read the question each time?
Okay, so if I understand the question, why do some species land on the endangered species list and others don't?
Right.
What a great question. And I think a lot of it ends up being politics, is the bottom line. There are a bunch of insects that should be on the endangered species list, but aren't because they don't have fur. Bottom line. Monarchs practically have fur, so that's why they're considering putting them on the red list right now. So that is kind of the decision-making process. But right now, if we can, and so when I'm talking with sometimes with beekeepers or something out in California, or some of the farmers out in California, they hate the smelt in the ocean out there. But these endangered species, because there's a lot of water use that are basically decisions being driven by a particular endangered species, right? And that ends up hampering agriculture throughout much of Central California. But what we need to remember is it's not about the damn smelt. Okay, we use an endangered species as a tool for entire habitats and entire communities of organisms that are oftentimes experiencing the same exact patterns as that one token species. And so, at least from a conservation point of view, yeah, you end up painting it's easy to dismiss, you know, a particular, oh, the damn rusty patch. Or when I'm going out to rangelands, we were working on Dakota skipper and Poweshiek skipperling, which are 2 endangered butterflies, royal pain in the ass to work with. But when you start talking with the ranchers, they're like, I hope you don't find them on my place. I don't need the Fish and Wildlife Service restricting what we can do on there. It's like, well, no, I mean, geez, I mean, if you're finding these on your farm, then you're doing something really right, you know? So I don't know. I think we need to change our perspective on some of those. But now I've waxed on about a topic that maybe you were interested in, maybe you weren't.
With the, as I understand it, there are 2 major pesticides sold in like hardware stores and things. And one is the organophosphates, and the other is the neonicotinoids. And as I understand it, the organophosphates kill, and then if the bug survives, gradually gets better. And the neonicotinoids, it's sort of a increasing dose. In other words, they are not recovering. And so the more they take, even if it's a week later or 2 weeks, that insect then becomes more and more distressed. Would that be correct?
No, I don't interpret it that. So, all right. So most insecticides that we're using right now are neurotoxins of one variety or another. They're fairly, actually, it's fairly limited in what their range of action is. Neonicotinoids and organophosphates function on different aspects of the nervous system of insects, slightly different aspects of the nervous system of insects. Neonicotinoids are systemic. You often treat a seed. Most of our field crops right now are treated with neonicotinoids. And then as the plant develops, it sucks up the insecticide from the seed, and it's transmitted throughout the young plants. And they've gotten a lot of press lately. The organophosphates have been around for decades, right? We've been playing around with these things since the 70s or even 60s. And we know that they're carcinogens and they're doing a lot of environmental harm. Yeah. Neonicotinoids were marketed as a silver bullet that's going to, you know, solve all your problems because it only kills the insects that are feeding on the plant, right? There's a number of problems with that interpretation. Number one is that marketing ploy. Number one is that only 2 to 20% of the actual compound that is put on the seed is taken up by the developing seedling, and that means 80 to 98% of that compound is shunted off into the environment somewhere. We don't know where. If it was your zinnias that you're treating and you're putting in your yard, that's one thing. Currently, neonics are applied on 13% of the terrestrial land surface of our country. The scale of the effects is profound. On one corn seed, there's enough neonicotinoid to kill 360,000 bees. On one corn seed. 360,000 bees. We're finding that it's systemic and it's being taken up in the environment. Plants, milkweed plants, 50% of those that we tested were hot at lethal doses for monarchs. We're finding that it's in conservation strips that we're putting out there to conserve beneficial insects. We're finding it on organic farms where we never treated those conservation mixes before.
You say that the milkweeds, which are big for monarchs, what percentage, and those milkweeds had not been treated?
Nope. 60% of the milkweeds were hot.
So they would be fatal to monarchs?
Yes.
Where did they get this from?
The neonics aren't staying put. They're getting into the water. They're getting into the soil. We just ran a tox assay on white-tailed deer. We couldn't keep the controls clean. It's in the water. It's in the forage that they're feeding on. Right? We tried a study where we used organic farms as a control and planted conservation mixes on these organic farms that were never supposed to have neonics on them. And then we compared that with bees that were put right next to, treated cornfields. They had the exact same contamination levels from the conservation mixes. The organic farms are contaminated at 10 times the lethal dose, the LD50 for honeybees. They were pulling it in. Scary stuff.
On the diversity issue, I understand how we can, through grazing, you can really restore prairies and plant species and get the diversity back. In the cropping systems, we can do a cover crop in rotation with our monocultures, and then we rotate our monoculture. When you're talking about the corn and building populations, of good insects around corn, how do you build that process when you only raise the corn every so many years? Better to stack it or continuous corn better?
No. I think that the rotation is part of that diversity that we're talking about. So, we just took a snapshot of the corn phase of the rotations, and almost, and I'll show data tomorrow, actually, part of which we did here in Burley County, where we compared just corn farmers that just put a cover crop before their corn phase and they didn't use insecticides versus guys that were investing up to $200 a bag in traits that were supposed to protect their plants. And the guys that used cover crops the guys who used insecticides on their corn had 10-fold more pests than the guys who just used a cover crop. It flies in the face of everything that we know. I'm going to love trying to get that published. But, it's quantitative, it's in the field, it's a system. And then the regenerative guys were twice as profitable. They eliminated a lot of their input costs, fertilizers and seed costs. So that's how you get the corn phase, for example. But also, there's a lot of guys that are starting to interseed legumes. One of my PhD students right now is working with a bunch of farmers on getting peas and legumes, things like vetch and clovers in between their corn rows. And that's a great way to diversify your cornfields. And your other crops too while you're at it. It replaces a lot of your input costs that way. It's just a good business decision.
One more question. How available are commercial seeds without treatment?
Yeah, so this is an issue, right? And so the neonics, what's really frustrating about them is that they don't seem to be helping farmers. Okay, in soybeans, we've got the data. It doesn't improve yields. It doesn't improve profit. In fact, you lose money. Sunflowers, corn. We're finding this time and again. How do you get seeds that are untreated? A lot of times you can't even find the seeds, right? We are working with Dakota Rural Action, a group in South Dakota, to get a website of seed distributors or seed dealers that sell, or seed producers, that sell untreated seeds. And that'll be available to the public, we're hoping.
One more along those lines. I can save seed on some plants.
Yep.
And control them. But there's a lot of the other seeds that I have to buy because they're patented.
Right.
And you can't keep the seed, so you have to buy that product. So what's the way around it?
So finding the seed dealers that are non-GMO seeds. And there's a growing number of small companies that are starting to do that, which is great. That's what we need, right? That's and hopefully that'll continue to diversify. But I agree, it's a challenge and it's a pain in the neck to try to find and to do the extra homework. But it's not impossible, and it's worth the money, I think. It's a good investment. Yes, sir?
I have a question about biological control critters. Why haven't they become more in use or more
available and plentiful or acceptable.
Why have biocontrol critters not become more mainstream, I guess, would be a way of saying that. And by biological control, I'm assuming, going to a store, buying a bag of lady beetles and then releasing it in your field or something to that effect. Or are you talking more about importation biocontrol, where you go overseas and find where the pest originated and then introduce it? Those are two general. I would argue that, so this is what I've studied for the last 20 years. This is the area of entomology that I've kind of specialized in, is predator ecology. I would argue that biocontrol is a major reason why diversified systems function. They don't have pests. Is because you've got a lot of native predators that have moved into that system, or at least endemic predators that have moved into that system and are filling that niche. There's a lot of question over I mean, it's a jug of a different color, to be honest with you, as far as releasing natural enemies. And in a lot of cases, I mean, there are some spectacular successes that have really gone on to really help farmers. But there's also a lot of snake oil that's been peddled over the years with biocontrol too. And so navigating those waters, and then where the hell does the money come from? I mean, it costs tens, if not hundreds of thousands of dollars to go overseas, pick up, find a parasitoid wasp that is specific for the emerald ash borer, bring it over here, do the safety testing to make sure that it doesn't sting a lot of the other native or ash borers or whatever, other buprestids in that case, to make sure that it's safe, and then release it and get it built up so that it actually doesn't impact on the emerald ash borer. Who pays for that? I mean, there isn't a jug that you can buy at the end that's supposed to pay for it all. And so biocontrol scientists have really struggled over the years in trying to find the budget for that kind of thing. I think it comes down to building a healthy system. And when you build a healthy system, the biocontrol is there and it functions. When you have an invasive pest, though, sometimes it does overcome that system until the native and natural enemies kind of reset themselves. We're seeing this with sugarcane aphid down south. We saw this with soybean aphid, I would argue. I think our natural enemies have done, I think it's time to reassess those treatment thresholds for soybean aphids. We see this frequently. Any other thoughts, concerns? Yeah.
Can you compare regenerative agriculture to multifunctional and precision?
All these buzzwords, huh? All these buzzwords, aren't they great? I think precision agriculture fits within the context of regenerative model. I think it's just a matter of maximizing the efficiency of resource use, and I think that fits well. Multifunctional, it sounds pretty similar to regenerative, I guess, but I don't know if there's a clear difference or not. We like to put labels on things. What else? All right, more.
Diversity is finally getting its due. Is it important in terms of what you discussed tonight, in terms of what contributes to that diversity? And what about scale?
Yeah. How do we get diversity on a grander scale? And this gets back to how do you change agriculture on a grander scale? Because that's ultimately what we end up having to do. How do we, and I've struggled with this. I was a Fed for many years. What we're talking about is a paradigm shift in how we've produced food. Paradigm shifts historically do not come from the government. They don't come from the government. They come from the bottom up, okay? And so that's why I quit, is because the farmers were doing things that the science said couldn't happen and the current paradigm said couldn't happen, right? And right now the large infrastructure is hell-bent on maintaining a paradigm, How do we make this thing work? How do we get more bushels out of this? I mean, we've got to feed the world, right? We got to have more bushels. I think it comes, how are we going to diversify Our food production system, how are we going to diversify our landscapes? It comes down, sounds crazy, but it comes down to healing rural communities and rebuilding those. Because as you start to diversify a food production system on a local level, suddenly you've got all of these opportunities for community interactions, and it all feeds, and people are successful out there again. And neighbors rely on one another again rather than buying another $500,000 combine. We replaced our rural communities with large machinery.
Jonathan, is there room for IPM anymore, or is that just kind of an old man myth now that we let go of?
IPM is dead as we know it, as it was originally designed. I'm not I'm not anti-chemical. I just think we need to be using our chemistries with the thought that there are consequences to using this stuff that are not on the jug. And I also think that you have to use it from a business perspective. I think that, fundamentally, there's some really good things about IPM, right?
People used to walk a field.
That was the best thing.
And if there was an issue, then they could look at the threshold level and
That's
see
right.
if it was the thing to do.
Right. Yep. So, fundamentally, what IPM was is knowing what the heck's in your field and not knee-jerk, prophylactic pest management doesn't work. We've known this for the last 50 years. If insecticides were the answers to insects, we'd have kicked their asses 50 years ago, right? That's not true. So, IPM, there are aspects of IPM that are great, but on the other hand, IPM is a reactive technique and technology. You figure out, okay, I've hit a level, and so now I got to do something. Rather than a proactive, which I think that these healthy systems that are really focused on soil health and biodiversity conservation, they don't have pests to begin with, so they don't have to react very often. That's the future. And it's not just insects, it's diseases, it's weed problems as well, or changing how we perceive weed problems. I've got half a field that's weedy as hell. You know what I've got? I've got 20 hair sheep that are grazing that down right now as I speak, right here. Hopefully Jenna will move those in the morning. I'm going to make money off of my weed control rather than spend money on herbicides. So that makes a lot of sense. That's just a good business decision, right? But that's where your diversified farm comes into play too.
If I might, just an observation from my standpoint, I work with farmers and ranchers every day. Information education, when you present these things to the producer, they don't all, want to make a test strip. A farmer rancher will find out that for themselves in their classroom, which is their field and their pastures, etc. And we do have an emphasis on that right now through the Farm Bill, the Conservation Stewardship Program. There's an enhancement in that that is very popular in my office, and it is using the PAM strategy, getting back to your fields, with that technique, and really, putting a lot of emphasis on, do you need to put an insecticide out there? Having that talk, and these guys are, they'll do what they need to do. They're curious too, and that's where you say grassroots driven. That once you get that going, the supply and demand thing kicks in, and there's a demand for it.
Right.
Neonicotinoid-free seed, if they're available and people are informed and educated on it, it'll go.
Yep, I totally agree. I think, what you're saying is absolutely true. I think that the education and where do farmers get that education, it becomes a really important question. Right now, you've got to follow the purse strings. I hate to say it, but you've got to follow the purse strings of where that information is coming from and how is it being manipulated. And that sounds, oh my gosh, he's an alarmist and all this other. I lived it for 11 years of my life of scientific suppression from the current infrastructure of information like on neonics and the new RNAi that was just approved. There are risks associated with this that people did not want you to see. Okay, where does that information come from? That becomes one issue that I think is really important. Is it unbiased? Farmers need to be evaluating these things for themselves. I totally agree. I think that they need to be, they're the best experimenters out there. And then finally, I think one thing that I would add is that these systems have to be sustainable on their own. If an incentive program gets farmers down a road, that's great. But then pull it back. We've got to get these, we've got to get them off the welfare checks. This is ridiculous. These systems have to pay for themselves. And let NRCS do the programmatic stuff that that's what you guys are trained for Christ's sake. Is developing these systems and interacting, not writing checks.
And we recognize too, there is risk with something new, and there risk.
But that's what Blue Dasher Nyctices was founded to try to remove some of those hurdles and risks. Yeah. Right now the farmers are the researchers as far as I'm concerned. The farmers are so far ahead of the science on most of these systems that I've abandoned trying to, I don't work on research farms anymore. I think that research farms are a bit of a joke, to be honest with you, now that I've just experienced more about the, and so I'm much more interested in working with the farmers that have defined these systems and made them work through trial and error. And understanding what those best management practices truly are, rather than me as a scientist saying, well, best management practices is, these 3 species in our cover mix, and then I have to terminate it at this particular time. No, it's adapted to your particular farm, right? And that experiential knowledge is beyond anything that the scientific community currently has.
So are there independent farmer bloggers out there that are sharing any information?
Yeah, there's a whole community that you start going on YouTube and you start Googling soil health and stuff, there's some amazing stuff going on. And support groups and that are starting to evolve as a result of that. So it's been pretty neat to watch. Yeah, we wouldn't be here if it wasn't for them, that's what's really cool. Yeah.
Mustard cover crops suppressing verticillium wilt, for instance. Do you have any exposure to that?
That's interesting that you should ask about that. So the farmers funded a research project. They were asking me about soybean cyst nematode. They said that brassica covers help, but there's no scientist that would touch it in the university systems. So they came to us and asked whether or not some of these brassica covers could help in pest suppression. I looked through the scientific literature. There really isn't anything that's been done on soybean cyst nematode, which is one of the biggest pests of soybeans. We just are finishing up our first assay on that system. So we evaluated 12 different brassicas that are all commercially available, and we infested those with soybean cyst nematodes. Okay, to get back to your verticillium question, so this is a general thought, is that there's disease and insect suppression and nematode suppression based on some of these cover mixes that we're able to get out there. The question then becomes, how does it work? And I don't think that we totally understand. The brassicas are neat in that they have a biofumigation kind of action. They have sulfur-containing glucosinolates and other secondary compounds that would get into the soil and help to resist certain, they're antibiotics more or less in the soil.
Well, my question stems from potato production. And there's been some movement on mustard cover crop.
Yeah? What have you been seeing?
Well, I don't have the data. think they've seen enough to continue.
Good.
And so the natural fumigation of a mustard cover crop for verticillium wilt, which is the major issue in Dakotas for potatoes. So that could bring cover crops to potato.
Absolutely. Well, you look at what Brendan Rocky's doing down in Colorado. You look at, you've seen other great potato producers that have integrated cover crops into their mix, and they don't apply a lot of pesticides anymore, if any. It's totally possible, even in those intensive crops.
Well, then due to our elevation, we get heat. If you're high enough elevation, verticillium wilt doesn't appear to
Not a problem.
potato. But if you're at our elevation in Dakotas, you're going to can.
So grow a healthier potato plant. And how do you get that? You feed the soil. You feed the soil biology. That's a huge component of that, right? That's a great, and then what is the function? Is it a trap crop? Is it aggregating other microbes that might be, antibiotic or predators of the verticillium? Or is it changing the potato plant because it trips a certain immune cascade in the potato plant? We do not know any of these questions, right? But they're all really good ones. Is there certain management effects on the function of those brassica cover crops, like planting it in a mix, killing it at a certain time, incorporating it in, this is the cutting edge that science is currently not addressing but needs to, and what we're hoping to do at Ecdysis.
I'm not clear, wasn't clear, I don't think, on my scale issue. Using your number of insects in your corn research, showed all those insects. Were they from that site, or were they from somewhere else?
No.
For example, if I drive by large areas of corn, 4, 5, 6 square miles of corn.
I'm sorry, say that again, that last statement. 4 to 5 miles.
4 square miles of corn.
Right. So these were, okay, so what we did is we'd go out, we contacted the 53 producers, point us to your cornfield, and then we would walk, the cornfield had to be at least 10 acres in size. Then we'd go in, and all of the insects community dynamics, be it pests or beneficials or whatever, were all taken off of the same exact corn plants. So, and then they were all localized within that particular area of the field where we sampled.
What I was trying to get at is if you've got 3 square miles of corn, 2 or 3 years in a row, how far is it? How important is a natural area that's not agriculture to the insect populations in that corn?
Right. So how far do the beneficials go into the cornfield? Is that one of the aspects of the question?
How far? Are they being raised in the corn?
Some of them are, but a lot of them aren't, right? And yeah, we actually studied that looking in soybeans down in Illinois, where we sprayed egg whites out onto soybeans and then egg whites onto prairie habitat. And any insects that walked on the eggs then were marked. And then we collected at certain increments into the soybean fields as well as certain increments into the prairie. And then we analyzed each of the bugs that we found on their feet for this particular protein, the egg protein, to see where they were dispersing. I still haven't analyzed that data. But what we're finding from similar studies is that they will disperse approximately 300 feet in a day, some of these species, per day. And so, but do they go in and then be like, oh man, there's not a lot out here, or I better get out of here again, or, so I've been recommending like conservation strips or diversifying your cropland in one way or another. We did it by growing sweet clover. So we grew, like in our soybean fields, we would every 300 feet or so this year, we've got a 20 to 40 foot strip of clover that we're going to harvest that provides additional resources, something else in that soybean field, and then we're building, because, oh man, you should see the stuff that lives in sweet clover. They just love it, right? And we have an annual sweet clover that we use. It's called Hubam. And we're one of the few people in the country that is producing that for seed, because it's going to be a miracle plant. But not a silver bullet, because I don't believe in those.
Jonathan, do you have any observations for gardeners with high tunnel versus outside gardening? Do you have any observations you can share with me?
I haven't worked with a lot of that. I think that the high tunnels restricts your insect communities. I think that it probably gives a situation that would disrupt some of the attractants to natural enemies. High tunnels are also one of these situations, though, where released biocontrol agents tend to function a little bit better. Usually when you go to one of these producers of natural enemies, you buy a little container of predators like lady beetles, and then you dump them in your field, and then you watch them as they fly to your neighbor's field. And so they really don't do much of anything in your own field. That's been documented time and again. But within a contained system, sometimes these released predators can be pretty effective. With that in mind, we're releasing predators into beehives to try to control the varroa mite, which is a bad pest of bees. It sucks the blood of bees. But we're releasing mite specialists into beehives to try to control those.
Is it working?
No. But we've got some other predators that we still have to try. We'll see. We'll give it time. We'll give it time.
I'm a gardener, but I've made a lot of mistakes. I've been following Jay's lead with fabric. Making mistakes. That's why I've been making mistakes. Actually, I've been successful using fabric. I've used it in the past. I'm now acquiring the fabric from Burley County, but actually I'm in Martin County. But so one of the so I have a high tunnel and I've lost the plastic 3 times. So, but it's still valuable for wind stress. So I protect it.
You don't have wind around here.
No, we don't. But there is diversity on the floor of the high tunnel with ants and crickets.
Cool.
And spiders and things like that.
Great.
But where I've lost the battle trying to, I don't use any insecticides or any type of herbicides. But bindweed is killing me, and Canadian thistle is killing me. And where I made my mistake is I started growing corn and potatoes and cultivated up my alfalfa. Now I want to go back to the alfalfa and forget about corn and potatoes, I think, and just stick with vegetables, raspberries, strawberries.
That's a lot of fun.
Rhubarb, that sort of thing. But do you have any suggestions on it? Is there any beneficials, 5 beneficials, that attack bindweed or Jenny and Canadian thistle? I know there is for
the thistles there is, yeah. For thistles, there's a number of natural enemies that have been released, and you've got them up here already. You have to build the habitat for them. And I think part of it is stress, and competition. How do you compete with those weeds and don't give them the free space that they need? So in our no-till garden, we mulch with chicken mulch, and that helps a lot. I mean, we just have chicken straw and stuff like that we lay down in the interrows, and we've got some weeds in there, but they're really not that big of an issue. And so, to me, that's just diversity.
Would any kind of mulch work?
So maybe, probably in certain circumstances. But there's good books about that have been written that I haven't read yet. And we have a lot of, I don't want to throw stuff away. And so we have a lot of chicken mulch with our or chicken bedding that we use with our birds, and so we've got 150 birds right now.
Quick question for her on the mulch. I happen to have loaned out a square baler, and I got given some square bales.
Oh, did you get some weed seeds in there?
Not the weed seeds, the straw. The crop had been treated.
Oh, yep.
Flat out they killed a whole bunch of growth.
You got to be really careful of that, and especially when they're burning down with paraquat and with glyphosate. I mean, that stuff, if you spread that all over your veggies, then guess what? And that's what, I mean, they may not admit it out there in the open, but that's what most of these wheat producers do, is they desiccate the crop with an herbicide. And paraquat makes glyphosate look like a walk in the park.
Yeah, but that killed those plants.
Oh, I'm sorry to hear that.
That was mulch.
Yeah.
But be careful where it comes from.
Yeah, good call.
Clippings from the wrong place can do that too.
Good call, yeah. Yeah, if you follow principles and work out the practices that fit your system, that's where you just don't go wrong. I mean, it just works. I can't tell it to you any more than that. I mean, I'm not a farmer. I'm not a beekeeper. Last year was our first jump into this, okay? And I mean, last year we netted $500 an acre. This year we're shooting for $2,000 an acre. It works. And I made so many mistakes. Oh my God. Yo, you don't want to see that. They're in our blogs, trust me. I don't know in 10 years whether I'm going to want to read that, but we've learned a lot. It makes me respect the hell out of farmers and ranchers and beekeepers a lot more than what I originally, I always said, oh, you know, I really respect these guys, but no, now I actually respect these guys and gals. I mean, they're...
One more question. I'm working real hard to enhance and restore biology in my soil.
Awesome.
How much relationship is there? It's like bulb goes out, there's the underground biology and there's the above ground biology.
It's all connected. Totally connected. Oh, and when you start looking into the how it's connected, it just blows your freaking mind. I mean, plants are communicating with each other. If there's an herbivore on a plant, so that plant, actually it has these, I happen to have a picture right here. It has these extrafloral nectaries. A lot of your plants have these things. It's a little cup there, right? And it's purple because it's ultraviolet actually. It looks purple to us, but to insects it's bright, you know. And it produces nectar out of that. And that's part of the plant's immune system. So what happens is that as something is eating that plant, it kicks out more sugar, water, or nectar out of its leaves. And then what comes along but a bunch of ants and lady beetles that then protect the plant from the herbivore. But what we're finding is that if you do one plant, its neighbor will start to kick out more nectar. And like, because through the soil there's connections through the roots and through the mycorrhizal associations, it blows my mind. Just blows my mind. And all of those things going on under the soil are totally changing the dynamics of your plant. Is IPM dead? Yeah. You want to know why? Because in a healthy soil, the same rules don't apply anymore. I don't believe any of the thresholds apply to our healthy soils. I mean, as far as like, oh, when you've got 250 aphids on your soybean plant, spray. I say BS. You've got a healthy plant there. You've got so many natural enemies that are reducing the soybean aphids. You've got a plant that can resist the soybean aphid damage. You've got, yeah, I mean, it's a different world. The same rules no longer apply.
One last question. Anyone? Appreciate everyone coming.
Wow, yeah.
Appreciate Dr. Lundgren.
Thank you guys.
To help us think about how we can move forward and apply soil health principles in a systems approach, and how we can start to connect the insect world and the soil food web world and diversity, and we can start to take a look at that entire connection. And I think we got to figure out how we can survive and move forward, as a community. How do we do this? How do we? Because isn't the end game still a good food product? It's still the end game. It needs to be, and I think we want that good food product at the end. So I think that this gives us a lot of food for thought. Appreciate your being with us.
Yep, thank you guys. I really appreciate coming out here again.